Live now.
You're live. Good afternoon, everyone. Thank you ever so much to everyone who's turned up. My name is Dave Barter, and I am from Nauto Guide, not Nauto Guide, as Nick called us earlier. And we are today's sponsor, your local sponsor. And there's only two of us in the business. And when you join our company, you get your own avatar. And that's Richard on the right-hand side. And that's me on the left. But my avatar was drawn before lockdown. So it's missing a couple of features. We did pay for your lunch out of our wages, being a two-man band. We did something quite extraordinary about 18 months ago, is that we completely changed our business model. Is we used to develop geospatial products and services and sell them to customers, and we used to hang on to the source code. And what we did 18 months ago is thought, hang on a minute, we've been in this business for 10 years, and it's built on open source software. Everything that we do is using open source software, and we don't open source much of what we do. So maybe we should change that. And in 2020, we open sourced absolutely everything that we do. We created a product and a platform called Lucaria, which we're still working on. There's a GitHub link there. You can go up to GitHub and you can download the entire system, and you can attempt to install it, and it's a little bit unstable at the moment, so it will probably blow up. But that's what we now base our business on, is we help people use our open source software to create things. And Lucaria came from a project with Surrey Heath, which was around about the same time as our revelation as that we should be good guys, not bad guys. And Surrey Heath approached us and they said, we've got all this geospatial data and it's in all sorts of different silos and all sorts of different formats. And we want to create a portal for our customers where we can show them various things about the area. Can you help us do that? And we came up with a concept of a system whereby we could consolidate geospatial data into a single view, and put an API on top of that view, and allow for complex searches from it, but also build a user interface so that you can create nice, simple websites that allow users to discover that site. And if you go to Surrey Heath's website, you'll see that now. If you click on My Surrey Heath, you'll see you can discover information about planning applications or car parks or schools or flood data, or your council tax bands simply by entering your postcode. And that's using an early version of our Lucaria open source product. But what I thought I would talk about today is the not our open source tool, because that's egotistical. I thought I'd talk about the shoulders of giants that I stand on, which I like to call my FOSS box. I'm going to trademark it, by the way, so if anyone rips that off me, my lawyer will be in touch. But my FOSS box is essentially the open source, the free open source software products, or are they products? I don't know. Things that I rely on. And what I'm going to do is I'm going to go through the ones that I couldn't survive without, and give you a few little examples as to how I use them. I think to anyone who's a developer like me in this industry, you'll recognise all of them, and you're welcome to show your appreciation by falling asleep. But for the rest of you who don't, maybe there's an odd snippet of something in there that would help you or make you think, oh, I could do it that way. And here they are. And as you can see, they're the usual suspects. So PostGIS, Postgres, Docker, GDAL, QGIS, and Python. If those cease to exist, I'm going to have to get out of the software development market and do something useful instead. So let's have a look at PostGIS Postgres from the start, is our whole business is built on Postgres as a database. There are other alternatives. There's MongoDB, there's MySQL, there's proprietary products such as Oracle and Microsoft SQL Server. But for anyone in the spatial marketplace who is not using Postgres, my message to you is you're mad. Because in my world, it's essential. But it's essential for me, strangely, for some things other than PostGIS, which I will talk about in a bit. And one of the things that we do, which is quite unusual, is we abstract all of our data logic into the database. So some people use things called ORMs, which kind of put a layer in front of the database that hides the SQL away. Other people write loads of SQL and embed it in their code, which is horrible. But what we do is we use the programming language PGSQL to embed our logic in the database. And for me, it's great because it means I can write data APIs in the database, and my business partner Richard, who only knows JavaScript, can simply make one single call to do something quite complex. He doesn't need to know anything about SQL at all or PostGIS at all. I've just abstracted it away from him from a single function. And I'm going to show you an example of this in a minute so that you can see what I'm talking about. But this is also important because in Postgres has amazing support for JSON. And anyone that's been a web developer knows that JavaScript works best with JSON, and it means that we can get data in and out of the database in JSON format. And in particular, one of the decisions that we took was to base our entire API around GeoJSON. So for us, displaying stuff on the map is really easy because we get some GeoJSON straight out of the database and we give it to open layers and it suddenly appears. And it also allows me to write tests that only test the data. This helps a lot when you're ingesting data from lots of different places, and sometimes the data is horrible or incorrect. Ordnance Survey, I'm looking at you. What you want to write is a whole series of tests that just test that your data is stored in the database correctly and it's in the right format and it says you're expecting. And we write our tests in Postgres and we run them in Postgres, and we can just test the database on its own and know that that's all working and not have to worry about all of the other components. And finally, using PostgreSQL functions, you've got reuse. So if you write a function that does something, I've got a function that runs a search using a nearest neighborhood algorithm, brings back a whole load of points, turns it into GeoJSON, then gives it back to the user. And I can use that function wherever I want, in whatever application I want. I don't have to take it out of one piece of code and drop it into another. It's there in the database and I can call it. And more importantly, when we have problems, so a customer rings up and says something isn't working, we can just run the function from the database and see what's going on directly. And finally, you can extend Postgres with other languages. And I'll show you an example in a second where we've used JavaScript within Postgres because it's made more sense than SQL. But if you're a Python programmer, you can actually program a database in Python, or if you're R, you can use an R extension. Finally, when you're using Postgres functions, you can write error traps. I'll show you one of these in a second, where if anything goes wrong in the function, you can trap it. You can give the user back a message saying, sorry, something's gone wrong, and you can log it, and you can deal with it later. Whereas when you're doing this in pure SQL, you're having to read horrible error messages and interpret them. So, and sorry, I forgot one other thing. There are some really good extensions that you can use. We use two. PG routing allows you to do exactly what it says, routing from point A to B in the database. So we've got functions where you give it 2 coordinates and it will produce the shortest path between the 2 of them, using either a cycling algorithm or a walking algorithm or a car algorithm, all within the database, no external code, no calls out, no network problems, no OSRM installs, nothing, straight in the database. And we also use PG cron, which allows us to run batch jobs within the database as well. Just to give you a couple of quick examples of this, I have to break out of PowerPoint in order to do that. Talk amongst yourselves. So this is my API. I've got a function in the database, and you send it a packet of JSON, and you just tell it what method you want to run. And my API says, okay, what does he want to do? Oh, he wants to list all the categories that we've got. And it then runs a function called list categories. And this is nice and easy, manageable code at the front of a database. The JavaScript guy or the web guy doesn't need to know anything about this. My API does it. And then down at the bottom, here's where I can trap errors. I can then use a logging function here to log that error away, but give the user back a nice simple message. And a sample of it is you literally call the API in this way. So it's a simple select statement. I want to run a search. I want you to search for town centre, and what that will return is GeoJSON in one single call. So it's really nice and easy to consume. Another function I've written here is a geocoder. So this function, again, won't go into the detail of it. You give it a postcode. So pass my home postcode to it, and it returns a nice little packet, an array of features that you can display on your map. And it will work with OS grid references, it will work with eastings and northings, it will work with lat longs, it will work with postcodes, and it's even got a regular expression that I'm really quite proud of that will pull a postcode out of text and geocode that. The JSON support in Postgres is immense, absolutely immense. So I can create a table with a column that is a JSON column. I can add an index to it, and I can then do a select. This select statement, I can give it a JSON document, and it will use the index to retrieve that, which means it's super fast. And it also means that you don't have to decide which columns you want to index as you would do in a normal table. You can make your mind up later once you're doing that. And there's even a language now in Postgres 14 which allows you to do some fairly complex JSON path constructions. So that's worth looking at as well. I talked about JavaScript. One of the things that we have to do is we get arrays of JSON, and sometimes they have duplicates in the arrays, and we want to return an array that doesn't have the duplicates in it. You try doing that in SQL, it'll be about 10 lines long. You do it in JavaScript, it's one single function here. So instead of having 10 lines of horrible SQL, I wrote a JavaScript function in the database. I give it an array with duplicates in, and it returns that array deduplicated. Here again is how we run tests. So this is a simple SQL test that's running a set parameters call and checking a result. So we can test all of our functionality within the database itself. So obviously, I'm a huge fan of Postgres. I'm a huge fan of Postgres as well because it includes PostGIS. And again, hands up who in here who knows what PostGIS is? Is it most people or not many people? Okay. PostGIS is an extension to the Postgres database that knows all about geography and GIS. So it includes hundreds of functions that deal with geometries, and it also includes loads of different geometry types and makes it really easy to work with GIS data. And we use PostGIS to do some quite clever stuff. So our lovely friends in the Ordnance Survey, they have data sets like ward boundaries, and they're very detailed. So if you try and display one of those or lots of them in a web browser, the browser eventually will blow up because there are too many points. So one of the things that we do is we load them into the database, and we use a PostGIS algorithm to simplify those geometries. And it's one single line of code that takes a complicated ward and simplifies it into fewer vertices. We use it for things like proximity and bounding box searches. So this is saying, give me this square, there's a square, give me all the points that lie within that square. One line of PostGIS. We use it for clustering. Some of our data sets are massive and you can't display them on a map, there are too many points. So again, PostGIS gives you some very powerful clustering mechanisms to say, look, I know I've got 1 million points, but show me them in clusters of 100,000. So I only get fewer points on my map and save time. And it also allows us to create something called vector tiles, which is a very performant way of showing map base layers in the database itself. And again, this is all nice and easy to do. Just to quickly run through some examples of how we do this. Here's how you do a bounding box search. Really, really simple. You just give it the bounding box and you use this operator, at. Couldn't be easier. And that will work on indexes and be very performant. Here's how you find the nearest thing to me. Using this operator, which is a distance operator, and you just pick the first one. So here I'm saying, get me something, get me some stuff, order them by distance from this point, and pick me the first one. So that'll get me the nearest one. Clustering gets a bit more involved because you have to decide what algorithm you're going to use to cluster points together. PostGIS supports dbScan and k-means out of the box, which are two different ways of doing it. But again, simple code. And vector tiles, one line of code, and I've turned my geometries into a mapbox vector tile. So again, very, very powerful things to do. So that's PostGIS. Has anyone fallen asleep yet? I haven't lost anyone yet. Okay. Is this interesting? Thank you. Who knows about GDAL? Oh, not many. Who has used GIS software? You naughty people, because GDAL underpins, as Tim said in his QGIS presentation earlier, just about everything. And GDAL is a whole library of highly clever and performant C functions that basically allow you to ingest, transform, and exhale GIS data, and it's kind of in everything. And we use it for loading data, for exporting data out of our system, and also transforming it. It's pretty good at turning it from one projection type to another, or adding various bits and pieces to it. I'm going to do just one very, very quick demo on GDAL. And GDAL comes with this command called OGR to OGR. It's got the worst name in the world for my favorite program ever. OGR to OGR will take very large files and do things with them very quickly. So here, what I've got is the Ordnance Survey open names dataset, and that's 2.7 million items. When Ordnance Survey give you this dataset, they don't give you the geometry, they just give you the coordinates, so you have to make the geometry yourself. And this command line here is simply saying, right, Ordnance Survey have named the geometry fields Geometry X and Geometry Y. They've got it in a projection of 27700, which is theirs. I want it in WGS 84. I only want 10 items. This is the file that it's in, and I want you to make that file. And so what I can do is probably increase my font size a bit. Where did I do this? I did it in the GDAL folder. I'll tell you what, I'll just run it. So we can run this. There we go. Oops, maybe we can spell it right. What have we done wrong there? I've done. Oh, I know. We should have plugged. We should have plugged in my drive properly, but I haven't done it. Anyway, what would have happened is it. No, I'm not having that. I'm going to do this right. Talk amongst yourselves. External. Here we go. It's going to. I'm going to do this because I want to show you how fast it is.
If you happen to have QGIS or use it or install it, all this comes in the command line. It kind of gets installed anyway, or it does get installed anyway. So you can use it. So you don't have to go and separately download all these tools.
There we are. Do you see that? You missed it. Okay. so now I have a file with 10 addresses that I've retrieved from 2.7 million Ordnance Survey ones. And GDAL gets more and more clever because what I can do is I can give it a bounding box. So here's the bounding box of Brixham, and I can say, just give me the points from Brixham. Or I can pass it some SQL, and I can say, look, what I want is the named roads. And I only want the field name 1, and it will give me that. Or I can do some cleverer things. So all I want is higher, names row named higher. And I want that as a G package file, or I can even output it as a CSV file. And again, picking the last command, this one's a little bit slower because it's got to go through all the records. But if I run that, you'll see, I guess in under 10 seconds, I've processed 2.7 million records. I've looked for the ones that are named higher. I've narrowed them down to a bounding box, and I've created them into a CSV file. And if we cat my Brixham higher thing, what was it? Brixham _ roads.csv, you can see there they are. There's 10. So this is an immensely powerful tool, and it's well worth getting your head around and understanding how to use it. Then there's Python, and Python, again, for anyone who hasn't come across it, I would argue is the language for geospatialists. There's almost nothing that you can't do in it. On the slide there, that's just a snapshot of the list of libraries that Python has that support GIS operations. And there are two things in particular that are worth looking at. One is a library called Pandas, and the other is a library called GeoPandas. And Pandas stands for Python something data abstraction library, or I can't remember off the top of my head. But what it does is it allows you to read files in almost any format very, very quickly into an internal structure and then process them. And in GeoPandas, I can do everything that I was doing in OGR to OGR and more, and I can embed it within my programs. So as an example here, let's have a look at, this is where I was opening my open names file. I was narrowing it down to a bounding box, and I was only including the name field. And you can see this is lovely, nice and easy, simple to understand code that is doing something great. Oh, sorry, you can't. Yeah. Let's just go back to PowerPoint. Let's go back to the code. There we go. A few lines of Python. I've read in the open names. I've narrowed them down to a bounding box. I've chosen that I only want field name 1. And what's also clever, if we go back to here, cd Python, And then if we run it, which one was this? GeoPandas on 3.py, and give it a few seconds, some magic's going to happen. I hope some magic is going to happen. Bear in mind, we have to read in 2.7 million address records, and bear in mind that the computer knows that I'm presenting, so it adds in those extra few seconds. But you can see in one line I was able to plot those on a map there, and this is great when you're working with data and you want to debug it and check that it's all going your way. Because if we go back to my code, what did I do? I just said plot. That was it. A single line of code. So let's move on quickly because I'm probably way over time. That's Python, which I absolutely rely on. And who here knows anything about Docker? Yeah, a few. Well, not many. In order to do this presentation today, I had to install Python and all sorts of libraries on this laptop. And my wife said to me, "Why the hell have you sitting in the corner swearing?" And it was because I'd run Python, it'd say, "Oh, you need this library." So I'd install that library and it would go, "Oh no, it's not the right version, I need the other one." And so I'd install that, and it just ended up in a massive swearathon because I'd forgotten to get all of these components on board before I ran it. Docker allows you to create environments where that is all done for you. So we use this all the time in our file loading scripts. If anyone's interested, we've got an open source version that talks to the OS API and will load anything from it. You just say, "I want to open and load open names," and it will do it. And it's this script file loader.py here, and it needs all of these things that you can see. And what I'm doing is I'm using a Docker container that OSGeo has created, and that Docker container contains all of the stuff that I need. And so in under 10 lines of code, I've created an environment that will run on any computer that supports Docker without me, by me typing a simple command saying Docker compose, and it will build that, and I then type Docker run, and it will run that for me. And I don't have to go through all of this whole installation malarkey and procedure, which is great. And we use this in the cloud environment. So we use a cloud service where you can spin up Docker instances as and when you want it. So in our system, when somebody uploads a file, it spins up our file loader, runs it, and then spins it down again and goes away. Really, really easy to develop with. Final piece of the pie, well, it wouldn't be a presentation without QGIS, would it? And again, for anyone who doesn't know QGIS, there are 3 reasons to use it. Well, actually 4. Number 1, it's brilliant. It's really easy, as Matt and also Dave showed earlier, just to display data in it. But number 2 is there's a huge community of plugins behind it. So if you are using QGIS and you find there's something you can't do, and you Google, how do I don't know, split a polygon into 6 pieces, the first answer will be, oh, you use this plugin. And you go into the QGIS plugin manager, search, and there it is. Install it, and you're splitting polygons into 6 pieces. But they're actually really easy to write yourself. I discovered this when I was loading GPX files into QGIS, because QGIS doesn't allow you to edit GPX files. It loads them in the read-only format, which is a real pain, because anyone that's used a GPX file for a cycling route or a walking route knows you want to edit it. So I thought, oh, that's annoying. I'm going to write my own feature to do that. And it took 100 lines of Python to create my own little GPX file manager, which I'm happy to show someone later, that loads in a GPX file and puts it into edit mode straight away. And I wasn't even a Python programmer when I did that. But the immense thing about it, which Dave showed earlier, is it's processing workflows. So when you find yourself doing the same procedure time and time again in QGIS and think, hang on, why am I clicking all these menus all the time? you can very quickly use the modeler and processing to create a model that will run that within a single click. And we've written some really, really complex models over the years. And when we find QGIS can't do something, it allows you to write Python code to do that thing that it can't do as well. So highly versatile and highly needed. I thought I mentioned a few other websites as well that we use along the way. I couldn't exist without geojason.io. Anyone that works in GeoJSON, sometimes it won't display on the map and you don't know why. Paste in geojason.io and it will tell you. And if it is good GeoJSON, it will display it for you instantly. Very, very useful website. Mapshaper.org again is similar, but allows you to do bits of analysis on the data that you've uploaded. And anyone that designs maps and doesn't use Color Brewer is nuts. Color Brewer is a color palette site designed for cartographers. So it helps you pick color palettes for you to make your maps work well and ensure that the colors are complementary. And then finally, you should all have this bookmarked in your browsers if you do anything to do with GIS. And this is a GitHub site of curated brilliant GIS things. There are hundreds and hundreds and hundreds of software packages, libraries, data sets, websites, you name it, they're there. Whenever I'm struggling to find something to do something, I go to that site and there's usually something there. So thank you all again for listening to me. I hope no one's asleep, so I hope there was the snippet or two of stuff in there that is useful to you. Presentation's up on GitHub. I know I skipped through it. There's quite a few code samples there. If you want to learn more and any questions, either shout now or grab me later.
Any questions? I'm sure there might be a few.
So thanks for that. That's great. Your example was focused a lot on vector data, simply GR to OGR,
Yep.
And Postgres stuff. I was just wondering what your preferred Python libraries for raster data were.
That's a terrible question for me, because I don't do much raster work at all. It's really odd. So I can't answer that question because I don't have a preferred one. What I do though with rasters is I did a project looking at DEM data to work out all the hills in the UK for road cyclists. And the way I did it is I loaded the rasters straight into PostGIS, made them into small rasters, and I then used the PostGIS raster functions on top of that.
Cool, thank you. And the other thing I was going to say, I was looking at, you talked about testing in PGSQL. Thought I'd shout out for PGTAP if anyone is interested in the framework testing Postgres. That's really cool.
Yeah.
You can sort of output standard output according to tests, and then run that from the command line.
PGTAP.
Yeah.
Okay, cool. Sounds good. Any other questions?
I was interested about the experience of making your code open source. It's something I've often thought about. I've got like 30 years of code.
Yeah.
And I've often thought, well, before I keep the bucket, I ought to make it all open source. But then it always feels quite a horrendous process to go through.
Well,
you go through a sort of cleaning and sanitizing of documentation, or just
no. I am walking naked down the street. It's as simple as that, is that we had to accept that there are bits of our code that are terrible. And I know they're terrible. And if you go and look in the repo, you'll find comments that say, this is terrible. And so I think you have to get to the point where you the reason you're doing it so other people can help you either improve it or they can use the stuff that you've done that is good, and you need to have both those mindsets. And so what where it changed us is it got us a different client base from people who were almost threatened by our technical capability to people who almost embrace it because they can see what we're doing, you know, and they can understand that the work we're doing for them is either, you know, meeting their requirements or terrible, please do it again day. When I say open source everything, I don't mean we took every bit of code out of the cupboard and put it up onto GitHub, by the way. Some stuff is staying in the cupboard because it truly is terrible.
Anyone else? I think you omitted something from your web resources, a GIS Stack Exchange. It's only when you ever needs a question answered. Thanks, Dave. There's no other questions. Just give Dave a round of applause. Thanks very much.
End the stream there. Brilliant. Right, so
cool. Right, so yeah, we're ahead of schedule by quite a bit.